is simply a formula that you can use. And what it does is it relates the angles and the side lengths of a triangle, and it does not need to be a 90-degree triangle at all. So this is the formula: the sine of angle A divided by side length A. And you'll notice that angle A and side length A are across from each other. So when you're setting up these problems, make sure that you understand the angle measure, which is the capital letter, is always across from the side length. And we usually denote that with the same letter, just lowercase. So is equal to sine of angle B over side length B. And that ratio is the same as sine of angle C across from side length C. So it's just a formula that you can use to find angle measures and side angles. And sides of triangles. So triangle ABC has angle A is 20, B is 35, and then lowercase b is 7. So if you were to draw a picture, look not to scale like this. A is 20 degrees, B is 35 degrees, and then side length B is 7. And that's going to be across from angle B. Please ignore my very loud cat. Okay, so I would do, so this is going to be side length A. It's across from angle A. And this would be side length C. It's across from angle C. So it's going to be sine of 20 degrees divided by A is equal to sine of 35 degrees over 7, which is equal to sine of C over side length C. So you can actually solve for one of these three things without having to use law of sines, and that's angle measure C, because angles in a triangle add up to be 180. So I could do this. C is equal to 180 minus 20 minus 35, and that is equal to 180 minus 55, which is 125 degrees. So now I have sine of 20 over A is equal to sine of 35 over 7. And then what I can do is, because I just have one variable that I'm solving for, A, I can cross multiply, and I would get A times sine of 35 is equal to 7 times sine of 20. And then to solve for A, I would divide by sine of 35. So once you set it up, then it's really just an algebra problem. And you just plug it into your calculator. I can't bring up my calculator right now on this video, but you would just plug this into your calculator exactly as written. Okay, you cannot divide out the signs. Don't try to do anything fancy. You can't divide the signs. You can't divide the 20 and the 35. It's 7 times sine of 25 or sine of 20 divided by the sine of 35. You cannot simplify this any further. You just plug it into your calculator. And then to solve for side length C, it's going to be similar. Sine of 35 over 7 is equal to sine of 125 over side length C. And then you would cross multiply and solve. So I'm going to let you finish the problem in your calculators. And just to the algebra, your honors pre-calc students, I believe that you can cross multiply and solve. Okay. Now, law of cosines is similar in that it's just a formula. So the formula is this. You're going to start with side length A, which is across from angle A. So A squared is equal to, and then it's going to be the other two side lengths squared and added, minus 2 times the other two side lengths, times, and that's law of cosine, so it's cosine of angle A. And you'll notice that side length A is all the way across from angle A. And then it's going to be the other two side lengths in the middle. Likewise, you can just change the variables. It could be b squared is equal to a squared plus c squared minus 2ac cosine b. You can also do c squared equals a squared plus b squared minus 2 times a times b cosine of c. And you might say, like, hey, this kind of looks like Pythagorean theorem. Well, Pythagorean theorem is law of cosines with a 90-degree angle. So if I were to plug that in, 90 degrees, what's the cosine of 90? Think about your unit circle. Cosine of 90 degrees is 0. And then this would go away, and you would just end up with c squared equals a squared plus b squared, which is Pythagorean theorem. So Just a fun fact there. But again, law of sines and law of cosines is really for when you don't have a right triangle. Okay, and then for number 3, we have triangle ABC. Okay, again, it's not going to be drawn to scale. That's okay. Angle A is 40 degrees. B is 9, and C is 7. Okay, well, how do you know that you're supposed to use law of cosines and not law of sines? So you'll look, if I were to try to set up law of sines, I'd have sine of 40 over, I don't know, and then you have sine of C over 7, and then you'd have sine of B over 9. Okay, well, I don't have enough information to solve for any of this because I have an unknown in every part of my ratio. Whereas up here, I knew one of the angle measures and the side length across from it, so that gave me a complete ratio. So if one of your ratios is complete, then you can solve. But if you do not have a complete ratio, then you cannot solve. So we use law of cosines when you have all 3 sides, or you have side, angle, side. Remember these from geometry? So if you have side, 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 or side, angle, side, you have to use law of cosines. If you have 2 angles and a side length, then you can use law of sines. And then, okay, so we're going to have to use law of cosines because I don't have enough information to finish one of my ratios. So I have this 40 degrees here, so I'm going to use the side length across from it, and I'm going to solve for that. So a squared is equal to 7 squared plus 9 squared minus 2 times 7 times 9 times cosine of 40 degrees. And by the way, you are in degrees mode in this entire chapter. I know it's weird. We've been doing radians a lot, but for this chapter, you're going to be using degrees mode. And then I would do a squared is equal to 49 plus 81. I mean, I would just do this all in my calculator. So, right, 2 times 63, 126. Cosine 40. Just make sure that you enter it as is. So I do 49 plus 81 minus 126 times cosine of 40. Do not do these 3 numbers first. Make sure that you have the 126 attached to the cosine of 40. Because remember, PEMDAS, the multiplication comes before you add or subtract. And then I would just take the square root, right? And then I would get A is equal to the square root of blah, 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 blah. Technically, when you take the square root, you need plus or minus, but it's a side length, so it's not going to be negative. And then to solve for the other angles and side lengths, so if I know what side length A is, so A is the square root of whatever, I just leave it in my calculator, then I can solve for my other angle measures. I'd be able to cross multiply. I would get A times sine of C is equal to 7 sine of 40. I would divide by sine C. And then, oh, I'm sorry. I would not divide by sine C. I would divide by A because C is my unknown here. So I would divide by A. And then I would, to undo sine to get C by itself, I would take the sine inverse of both sides. And again, I would leave this all into my calculator all at once. And I would do sine inverse of all of that all at once. Okay. Now, I just want to point out one side note here that I want you to kind of just write down and keep in mind as you do these problems. If you are given a side, side, side case, always solve for the largest angle measure. You have to solve for the largest angle measure. The reason you want to do that is because there is such thing as the ambiguous case of law of sines. And if you use the largest angle measure, you'll avoid the ambiguous case. And I know it's hard. You'll see in the next video what the ambiguous case is, but basically sometimes law of sines results in 2 answers. And to avoid that with a side, side, side issue, solve for the largest angle measure, and then you shouldn't have any issues with the ambiguous case. So just take my word for it. If you're given side, 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 solve for the largest angle measure.